In this video, I'm going to show you how to extract information from word problems so that you can formulate two simultaneous equations that you can then solve. But I'm going to skip over the solution part straight to the answers, as I've covered that in other videos elsewhere. And that will enable us to get through more examples. Now, the most important thing by far is to make sure that you are able to define what each variable, that is each letter, actually stands for very carefully. And if you can do that, then you really won't have many problems with this type of work. So let's begin with this very simple example. I'm thinking of two numbers. 3 times the first number plus twice the second number is 38. 5 times the first number plus 7 times the second number is 89. What are the two numbers? Now, first we need to decide what letters we're going to use to represent the two numbers. So let's use P and Q. We need to write this down so the examiner knows exactly what we're doing. Let the two numbers be P and Q. In a very simple example like this may seem trivial, but it's good practice for what's coming. Now we can piece the first equation together. 3 times the first number is obviously 3p, and twice the second number is 2q, so we have 3p plus 2q is 38. And working similarly with the next piece of information, we can formulate the second equation, which is 5p plus 7q equals 89. Now, if we solve these equations, and I'm going to miss that bit out here, we will find that p is 8 and q is 7. So now we finish by saying that the two numbers are 8 and 7. It's not really sufficient to finish by saying p equals 8, q equals 7, as that doesn't really answer the question. Well, that was quite easy, I'm sure you'll agree. So let's try a harder example. Electricity from Electgriddle is priced in the following way. Firstly, there's a standard charge per month, and secondly, there's a cost per unit of electricity used. Mrs. G used 2,100 units and was charged £146.50. Mr. B used 2,900 units and was charged £194.50. Write a formula connecting the unit cost, the standing charge, the number of units and the total cost per month. And then find the unit cost and the standing charge. Now, the standing charge is normally a fairly large sum that would be given in pounds, and the unit cost is normally quite small, so that would be given in pence. So we must begin by deciding whether we're going to work entirely in pounds or entirely in pence. Now, this may sound obvious, but many students try to mix the two and end up with some very strange equations. We're going to work in pence, because if we work in pounds, we'll be dealing with decimals of a pound for the pence, and that makes it more prone to error. Now, the next thing we must do is to define the variables we're going to use very carefully. Let's begin with the unit cost. We write, let C be the unit cost in pence. Notice the words in pence. This not only tells the examiner what we're doing, it also makes it clear in our minds that we're dealing with pence and not pounds. Similarly, S will be the standing charge in pence, N the number of units used, and T the total cost, again in pence, per month, and we can add these onto the end of that sentence. Now, the total cost will be the number of units multiplied by the unit cost, plus the standing charge, of course, which gives T equals NC plus S. And that's the formula part done. Now we need to work out the actual unit cost and the standing charge, and for that we make two simultaneous equations from the information given. Looking at what Mrs. G paid and working entirely in pence, we have 2,100C plus S equals 14,650. And doing the same for the cost of Mr. B's electricity, we have 2,900C plus S equals 19,450. Now, as before, I'm not going to work through how to solve these equations. That's done elsewhere. I'll just tell you that solving these gives C equals 6 and S gives 2,050. But the examiners want to know what the unit charge and the standing charge are, not the values of just C and S as letters. So we must finish off with the following sentence. The cost per unit is 6p and the standing charge is £20.50, remembering to change the standing charge to pounds at the last minute. Now I hope you can see how important it is to write down exactly what the variables we're going to use are, and where appropriate, the units they have. This really clarifies our thinking. And so, to our third problem. In a safari park, keepers keep records of the animals' masses. 3 elephants and 5 chimps have a combined mass of 10.71 tonnes, and 7 elephants and 8 chimps have a mass of 24.836 tonnes, assuming an average mass for each creature. What are the average masses of the elephants and the chimpanzees? Well, I'm sure you can see what the problem is here. The elephants are very large and their masses would be measured in tonnes, whereas the chimps are much smaller and are therefore weighed in kilograms. The question is, do we work in kilograms or tonnes? Because if we don't decide early on, we're going to get the units well and truly mixed up. With this type of problem, it's generally better to work in the smaller units. You'll remember that we worked in pence in the last problem, and this generally avoids the increased chance of error with a lot of decimals. So we'll work in kilograms, and we need to remember that 1 tonne is 1,000 kilograms. Again, we must define our variables very carefully. So we write E is the average mass of an elephant in kilograms. C is the average mass of a chimpanzee in kilograms. By doing this, we have first defined that the variables stand for masses and not for the numbers of animals, for example. And secondly, we have stated that we're working in kilograms. So, extracting the information from the question, we can see that 3E plus 5C equals 10,710. That's changing the tonnes to kilograms as we go. And 7E plus 8C is 24,836. Now, when you solve these equations, you'll find that E is 3,500 and C is 42. Now, these are in kilograms, don't forget, so we must now write down the answer to the question. And the answers are, the average mass of the elephants is 3,500 kilograms, which is 3.5 tonnes. Now in this case you could give the masses of the elephants in kilograms or in tonnes, so long as you clearly state the units you're using. And the average mass of the chimpanzees is 42 kilograms. Well, I hope that's helped you to see how important it is to clearly define the variables you're using and how to extract the information from the question so that you can formulate 2 simultaneous equations which you can then solve. And don't forget to answer the question at the end. Don't just give the values of your variables.